Okay, so a biomedical signal processing unit uses a logic system defined by the Boolean functions. Why? So we are on question 3 now. Okay, so question 3. So we have y. Okay, let me just try to go up there. Okay, so we have y. We have y is equals to, we have y equals to, what do we have? We have a b c. Okay, we have a b c. Okay, so we have a b c. So let's just write here a comma b comma c comma d. Okay, which is equals to the equation given there. We have a. Okay, so open parenthesis there. We have a plus b prime, or not b, b prime c, close the parenthesis, open another parenthesis, a prime, or not a, plus d. Okay, so if we're going, yeah, so this is what we have now. They're saying that using De Morgan's theorem, um, use De Morgan's theorem to simplify the expression. So they want us to simplify this expression using De Morgan's theorem. So we are going to use the product rule. Okay, so now with the Boolean algebra, there are words that they do use. Like for example, if you're multiplying, like if it is a dot b, so this one they say it is a and b. Okay, but if you have a plus b, they say to say this is a or b. A plus b, they'll say that this is a or b. But a dot b, they'll say this is a and what? This is a and b. Okay, so we're not going to be using these terms because you're going to get confused whilst I'm be solving. So let me just stick to the a plus thing that you know. Okay, so now with this one here, we're going to have, we use De Morgan's theorem. So we have a plus b prime, or not b, c, you close the parenthesis there. Okay, open another parenthesis, so to be a, okay, prime, or not a, plus d. So it's just a matter of multiplication. This one you just multiply direct, the way we do multiply when we're dealing with the algebra. I mean, when we are dealing with algebra. So to be a multiplies everything inside the parentheses here, as well as when we're done with a, we go to not b or prime b, c, and multiplies everything there in what, in the parentheses there. Okay, so this is what we're going to do. So a multiplied by a prime, we're going to have a prime, okay, plus a multiplied by d, you're going to have plus a d. Okay, we're done with a. We go to not b, c, or prime b, c. So prime b, c multiplied by prime a, we're going to have plus a prime b prime c. Okay, from there plus prime bc multiplied by d, we're going to have prime bc d. Okay, this is what we're going to have. Now note that a uh, a a prime is equals to 0. Okay, so we are using the absorption rule. So now the absorption rule, this is what you're going to have. A prime is equals to what? Is equals to 0. So from what we have, so we substitute a prime equals to what? 0. So we're going to have 0 plus a d plus a prime b prime c plus b prime cd. Okay, this is what we're going to have. And if you look at bc, okay, so here of prime b and c, also here of prime b and c, so we're going to forget about this, like, because this becomes redundant. Okay, so we are going to concentrate on a plus 0 plus ad plus a prime b prime c. So this is what we're going to have. So we're going to have ad, therefore y equals to ad plus a prime, okay, b prime c. So this one becomes our final answer. This is how we solve using the De Morgan's theory. So from there, okay, so from there we go to question what? B. So question B, the question reads, construct using what? K-maps here. Construct using the K-maps for function y. So construct this what we have using the, I'll use a different pen here. Construct what we, this one what we've solved using the what? The K-map. So we have how many input do we have? We have A, B, C, and D. So we have 4. So we're going to have something like this. I will use a straight line here. Okay, so this is the straight line that we have. Okay, so I'll use a straight line here so that it can come up with something something representable. Okay, so from there, since we have 4, we're going to have 4 rows, 4 columns. Okay, so 4 rows, 4 columns. We have that 1, 2, 2, 3, 3, and the last one here. Okay, so that one becomes our last column that we are going to have. Okay, so from, okay, our last column. So from here, okay, we have that. Okay, so this is what we are going to have. Okay, so let me just try to touch it so that we can have something something clear. Okay, from there we have 1, 2, 3, and 4. Okay, so we have 1, 2, 3, 4. Okay, so from there, this is what we are going to have. Okay, I'll use blue here. Oops, red. Okay, all right, so we have, so this one becomes our A. Oops. Okay, so we have our A, so this one is our A here. So we have A, B, C, D. Okay, so this is 0, 0, 0, 1, 1, 1, and 1, 0. Okay, so same applies to C, D. We have 0, 0 here, 0, 1, 1, 1, and 1, 0. Okay, so if we look at the function that we have for y, we have y is equals to AD plus A prime B prime C. Okay, so this is our A. So our, where there's A, we put 1, also here 1. But if it is a prime or not A or not B, not C, we're going to be putting 0. So I have AA. So where is A? When we come to the table that we have here, the map that we have, where A is 1, that's why we're going to be dwelling from. Yeah, okay, so where A is 1, so we have AB. So our A, this one, if you look at this one, our A here is 0. If you look at this one, A here is 0, but B is 1. If you look at this one here, A is 1. Okay, so A is 1 here, as well as here A is 1. Okay, so this is where we are going to put our what? We are going to put the ones here in our boxes. So 1 from this point and 1 from this point. Okay, so what about that of D? If you go to D, D is 1 where? D is 1, so D is 1 here as well as down there. So here as well as down there. Okay, so we have these two. So this is what we are going to draw here. So D is, let me just try to erase this because I was just trying to show you. Okay, so we put the ones where those two does what? Intersect from. Okay, so this is where what we are going to have. So meaning our D, okay, so our D, AB, I mean our A is positive. I mean our A is 1 here and there on the second last and the last. Then D, again, we have D is, D is 1 here, okay, as well as this point. So where these two they intersect, so this is where our one are going to be marked from. Okay, So we have one here as well as one there. Okay, so this is where they're meeting from. Then we go to note A. If it is not, you put a 0. If it is not, you put a 0, but this is just C, we put 1 there. So where A and B are zeros, where A and B are zeros, so we have these two. Okay, this is where A and B are zeros. Now where C is 1, we go to the C. So C is 1 here and there. Okay, so where these two they meet from, that's where we are going to do what? To put our 0. So we have this part here and this part here. We are done. Then the rest we do what? We put the zeros. Okay. So this is how we come up with what? We come up with this is how we come up with the K-map. Okay. So you can have A, B, C, D. Others they can even try to come up with something like this. Let me just try to draw another table here, a similar one. So for example, if you have C, D, A, B. Okay, so others they can even swap it still. Okay, you can even swap if you want. Okay, let me just try to show you what you can come up with when you swap these. Okay, so when you swap these, you're going to have that. So we have that line, and the last one. Okay, so if you swap these, so you have 1, 2, 3, and the last one. Okay, so in case you swapped there, also we have 1, 2, 3, 4. Okay, so in case you swapped your what? You swapped your letters, you can have C, D, A, B still. Okay, so we're going to have 0, 0 here, 0, 1, 1, 1. Oops, we have missed on something. Okay, let me just try to get this and throw it somewhere. Okay, do we have space up there? Just want to show you something. Okay, so we can get this and try to move it somewhere. Okay, so let me just try to get this and move it here. Okay, let me try to move it there. Okay, so we are going to have another box there. So we're going to have another box. Okay, so we are going to have another box there. Okay, for this, so we have that. Okay, even if you try to swap them, still you're going to have the same answers, just be able to find out where they are intersecting from, where they are meeting from. Okay, so meaning this is what we are going to have. Okay, so this is what we are going to have. To draw the K-map is so simple. Come up with a K-map. So we have 0, 0 here. Okay, 0, 1, 1, 1, and 1, 0. Okay, so same applies to this. We have 0, 0 here, 0, 1, 1, 1, and 1, 0. Okay, so from there, they're saying that AD is what? AD, I'll use a red pen here. So they're saying that A is what? A is 1. So where A is 1, where? So we have this point at this and this one. This is where A is 1. Okay. Excuse me. Then we go to D. Where D is 1, we follow D. So D is 1 where? D is 1 here. Okay. Here as well as here. D is 1. Okay. So where these they meet from? So it is this point here. So we're going to have this point here, that point here, as well as there. Okay, that is where they are meeting from. Okay, with the A. Let me just try to draw this line there. Okay, so that is where they're meeting from, with what? With the A. So if you draw that, we go back now to what? To note A and note B, C. So note A, note B, they are 0, 0. Note A, note B, they are 0, 0. So this is where our 0, 0 are from. So now C is what? C is 1. So we go where C is 1. So C is 1 here. Also not this one, but C is 1 here. Okay, as well as there. Okay, so where now this one they're meeting from this point here. So C is 1 here as well as there. Okay, so this is what we are going to have. Then now the rest, what do we do? The rest we put the zeros. So we're going to put 0 here, 0 there, 0 here. Okay, all the spaces, these the blank spaces, we put the zeros. So this is what we are going to have when you're dealing with what? When you're dealing with what's this? De Morgan's theorem, then you use K-maps now. So this is what you are going to have. So if you look at this one of 1, 2, 3, 4, this is the box that you're going to have here. This one together with that. Okay. So if you come to this one, this was C, D, A, B. So if you come to this one, you're going to have, this is the box that we have here. Okay. As well as that. So it's just one and the same thing. You can still use, you can go by this route, A, B, C, D, or C, D, A, B. Still works for you. Okay. So now with this, then the last question says, that was question B. Because question B, it was construct a K-map, um, construct a K-map for function y. So we've constructed. Then now, from your simplified expression, draw the logic circuit diagram. So now let's draw the logic circuit diagram. So the logic circuit diagram, it will be easy for us to come up with this, right? Because we have already constructed the what? The function, and we already know the function, I mean. Okay, so the function, remember that we are just, the function we have y. What is our function? Let me just try to copy it. Okay, so this is our function there. That's our function. So I'll copy the function, the function, and I'll paste it from here. Okay, so this is our function. Now, with this function here, what are we going to do? So with this function here, they want us to come up with what? The logic circuit. So we have y is equals to AD. So AD, so we're going to write this is our A, this is our D. Oops. Let me just try to use something. Okay, let me just try to erase this so that we can have a space here. Without wasting much of the time, we can just erase this so that we can have a space here. Okay, so we have a space there. Okay, so this is what we are going to do. So for us to come up with what's this, the logic circuit diagram, we have AD. So we just draw we just write A and D there. Okay, so A and D there, we have AND gate. Okay, so this is our AND gate that we're going to have. Okay, then what else? A not, not A, not B, C. So let's just write them down here. A, B, and C. So these are not here. So they have to all go into what? Into an AND gate. You can have an AND gate there. Okay, they are all going into an AND gate. And from there now, remember that when we add these two, we're supposed to come up with what? We are supposed to come up with an OR gate. That's where they are going. So this is where an OR gate will come from now. Okay, that one becomes an OR gate. This is our OR gate now here, which is equals to what? Which is equals to y, which is equals to y. Okay, so it ends there. So this is our OR gate. This is our OR gate, what you're going to have. So now A, B, so this one here, if you are going to have A, not what? B. Okay, so we're going to have not A, not B, C. For this one we're going to have A, D. Okay, so now if you add the two, this is what you're going to have there. So our y is equals to A, D plus AD plus not A, B, and C. Okay, so this is our y. Okay, so it ends there without wasting much of the time of you writing, no, this is my gate. I put a note there and like, so this is what you're going to have. Okay, we'll go to question 4. We move to question 4, and the question 4, the question reads,